Hi again. This is ECE 109, Introduction to Electrical Engineering, Lecture Note 3. In this section, we're going to cover the Kirchhoff laws. Basically, in this section, we're going to mention about the branch, nodes, and loops. Then we're going to go to Kirchhoff Current Laws, Kirchhoff's Voltage Laws. Um, what is a branch, node, and loops? Branch represents basically a single element on the circuit, such as voltage source, current source, resistor. So between two terminals, any connection that will be represented basically the branch. If you look at in this circuit, we have voltage here as a branch. 4K, we have a branch. I'll change the color. We're gonna have 4K, another is branch, another one is 2K, and 3 milliampere. Those are the branch. The node is a point of connection between two or more branch. When we look at here is 20 volts and 4K joined together. This is one node here. If you look at here, there is another right here as a we call B here. That's another node here, and we have another one here also. This is the node 2. Mainly this one we call a common node there. Um, the other one is a loop. Loop is any closed path in the circuit, and we show this one is a green color here. We have one this way is going, another one is here this way here. This is the direction I select this direction, but you see we have three different loops. We can represent the same circuit with this way too also. Nothing is different. If you look at this one here, this circuit, we have one, two, three, four, and five branch. We have one voltage source, one current source, including the branch. We have A, B, and C nodes, and we have also three different loops as we show green. Let me give one example to make it clear here. We give one this example here. We're gonna find how many branch nodes and loops we have in this circuit. We see here, find the branch first. I'll change the color black here maybe. This is one, this is two, this is three, this is four, and this is five. So we have five branches. And nodes, let me change the color to maybe red here. This is combination, right? Combine them right there, joint. This is one of the nodes, A. The other nodes here as B. The other one is here as C. C is also we call common node too also. As a loop in this case, we have one loop right there, another loop right there, another loop right there, independent loops. Those are the three loops. So we will use those terms later. So that's why it's good to know now. First, let's focus on the Kirchhoff's current law. We call it KCL. Kirchhoff current law states that the algebraic sum of the currents entering any nodes will be equal to 0. The sum of the currents entering any node will be equal to 0. That means the sum of the current entering the node equal the sum of the current leaving the nodes. In my case, if this is the node right there, uh, uh, the entering the node I will use as positive, leaving the node I will use as negative. If somebody do different opposite, that will be fine too also. So this way I1 entering the nodes, that's by positive, I2 exits negative, I3 positive, I4 is positive, and I5 leaves negative, will be equal 0. So you can put a negative positive one side if you want. Let's see if we can give a sum in this case here. In this circuit here we have three current sources. They have different direction. So we need to find the I of t here. I of t is I or IT exiting, that's why I call negative right there. I1 is going entering the node because this is the my node right there. Okay, that's why we call I1 here. I2 is exit, that's why we call I2 here. And I3 entering the node, that's why we call positive equal 0. If you leave IT alone here, then will be equal I1 minus I2 plus I3. So this is the way we can find the equivalent current sources. Another example here, given in this circuit here, that we're gonna find the I1, and I2. Okay, and you can see 20 volts voltage over the R1 and R2. Basically, using Ohm laws, we know that I1 will be equal V divided by R1, which is 20 volts divided by 1K. That will give it 20 milliamperes. The second resistance value over the second value, you have same voltage value again, V over R2. That's why you can find I2 is equal to 20 divided by 4K, which give you 5 milliampere. So applying KCL in this node here, which is all combine them together, right? You can see here. Okay, so I entering the right there positive will be equal I1 and I2 exiting right there. So that's why 20 plus 5 will be 25 milliampere. We haven't seen, but if we combine two resistor to find total resistor, R1 times R2 divided by R1 plus R2, that give you 800 ohms. In that case, using the ohm laws, we can find the V over RT, which is give you 25 milliampere too also. This is another way to check your result. Let's give another example. This case, we have a current source right there, not voltage source. So that means we know the I value. So we need to find I1 and I2. We know that I will be equal I1 plus I2. That's why it's given to you right there. And we know the I again 10 milliamperes. Okay? So if we apply, if you're using the Ohm laws, okay, 10 milliampere current right there. Again, I is equal I1 plus, let me put this one right there. I is equal I1 plus I2. I1 will be equal V over R2 plus I2 will be equal V over R3 plus R4 basically. So this will be I, which is, we know the I value is 10 milliampere. Okay, so that's why 10 milliampere will be equal V1 divided by 6K plus V1 divided by 10K. 6K plus 4K plus 6A will be 10K right there. So in this case, we can find the voltage over this point here. As soon as you find the voltage here, you can find I1 and I2 using the Ohm laws basically. Okay, that's why I1 will be equal V1 over R2. I2 will be V1 over R3 plus R4. Okay, if you say I want to find the voltage over the only R4, in this case V4 will be equal I2 times 6K. That's why we can find this one here too. How about the Kirchhoff's voltage law? We call KVL. Similar to KCL, KVL state that the algebraic sum of the voltage around the closed loop will be equal 0. So in this case, sum of the voltage around the closed loop will be equal 0. So if it's a loop serial case, we can apply KVL. In this case, I look at here, we select direction is like this here. That's why entering the negative right there. That's why we have V1. This is positive here. That's why we call V2 here. This is positive right there. That's why we call positive V3 here. And then next one is negative. This case here, that's why we call negative V4. And this is positive here. That's why we call plus V5 here. So this is the way we can define the closed loop voltage. Okay. In here, if we know the voltage V1 and voltage V2, we can apply Ohm laws for V2, V3, and V5 to find the current first. After the current, we can find the each voltage V2, V4, and V5. Here's the example. So we need to find the V1. We need to find V2. We can find multiple way, but let's apply a KVL in this case here. First of all, what is V1 equal? V1 will be equal I times 2K. If we select this I, this direction, entering the positive, that's why we have it. Same way, V2 will be equal, because of positive here, I times 3K. Applying KVL, minus 20 volts plus V1 plus V2 equal 0. So V1 is equal I times 2K, right there. V2 is I times 3K, then equals 0. We have only unknown is I, then we can find I first. If we know the I, then easy, using the this equation and this equation here, we can find V1 and V2. That's why V1 will be equal 8 volt, V2 will be equal 12 volts. So basically negative 20 plus V1 plus V2 equals 0. So here we have negative 20 plus 8 plus 12 equals 0, which is equals 0. Makes sense. In this example, we have two voltage sources, V1 and V4. So we need to find V2 and V3. First, using Ohm laws, V2 will be equal, if we select the current this direction here, V2 will be equal I times 2K, then V3 will be equal I times 3K. That's given here. So applying KVL, minus 24 volts plus V2 plus V3 and plus, because a plus right there is 12, will be equal 0. So V2 plus V3 will be equal 0. Applying previous Ohm V2 and V3 here, so you can have 2K times I plus 3K times I will be equal to 12. Then we can find the I from here. 12 divided by 5K, that will be equal to 2.4 milliampere. To find the V2 and V3, we're gonna use again these two equations because we know the I times 2K give you V2. Then next one is here, I times 3K give you V3. Okay, see you in the next class.